This week I've been inspired by a question that came from a viewer concerning one of the videos I did quite a long while ago now on the state pattern. And the question wasn't anything to do specifically with the state pattern, but on just a couple of lines of code that they'd seen in the example and that hadn't really made sense to them. So that's what we're going to be looking at this week. And the line of code in question was actually this one here. So where we say public light this, square brackets, pelican lights li gives underscore lights int li. Now that is an example of something that's pretty fundamental to C#, been around right since the beginning, which is what is known as an indexer. So this week I thought I'd talk about indexers and look at them in general, get on to exactly what's happening there and show a few other things as well. So just to show you what this application was, this was the one from the state pattern. If I run it up, it was just simply giving us, if I drag that over, this set of traffic lights from a pelican crossing, and when I press the button, the wait light comes on, and then the traffic light goes through its steps for what we have with the pelican crossing. So that's something, if you want to watch that older video, do have a look at that. But to start with, let's move to a different project where we can just see what these things called indexes do. So let's just set that as a startup project and then go in there, and just to start with, just to show you what an indexer is, it's simply the sort of thing we have with an array. So if I say int array ints equals 1, 2, 3, and then if I say ints element 2, then that use of the square brackets is what's known as an indexer. So sometimes called square brackets, sometimes called a subscript, but indexer is strictly the term in C#. And we can assign into that, or we could also read from it. So I can do a console write of ints 1 or something like that. That's what an indexer is. And that's available on something like an array. It's also available on something like a dictionary or a list or several other collections as well. And we can write them for ourselves too. So the example I put together here, I've got just a simple class of a book that's got a title and a year and a toString to display those. And then what I'm doing is putting together another collection that's specifically there to deal with book series. So where we've got multiple books in a series. And so what I've done for that is created a private dictionary where the string key is the name of the series, and then the value is a list of the books in the series. And so you can see I've just in the constructor set up some dummy data. So we've got the 7 books of the Chronicles of Narnia, 7 books of Harry Potter, 5 books of the Danilov Quintet, 3 books of His Dark Materials. So we've got the dictionary of a list. And then in there, I've just put in a toString so we can loop through those. And also, because the value here is a list of books, I've put an extension method as a toString for that, so we can just easily list out those books. And so if we just go back to our program here, put in that library, we should just, if I do a console write of that, be able to look at the library. It'll call the toString, and there we've got those 4 series listed out. So what we want to do is put an indexer on that. And let's put a very simple one on there first. So all I'm going to do is say public, and then the return type, and that is going to be our list of books. So that's going to return an entire series. And then the thing that makes an indexer is we use the keyword this. Now this is a keyword that's used in lots of contexts in C#. Its primary meaning is simply to refer to this object itself when we're inside a class, but we also know it's used for things like extension methods, and here, probably one of the least intuitive uses of this is how we declare an indexer. So if I say this, and then in square brackets, because it's an indexer, we put what the index parameter is. So I could, in a simple case, and this is similar to what we have with arrays or lists, I could just put int, and then let's call that idx, short for index. And then an indexer is very much like a property in that we have a get and a set. So I could put a get in there, and on that one just say return, and then we'd go to our series. And then I can't use that index into the series because the series, remember, is keyed on a string. So I've got to do a bit of a trick to get at the element by position in a dictionary. So I have to say dot values and then dot element at and then idx. And that should give me back the list of books at position 0, position 1, whatever it may be. And then just like a property, I could also have a setter as well, but we'll just leave it as the getter for now, but that will mean that we can get at a particular position. So I've also got a count in there, which means back in the program, I could now, on that library, do a for int I equals 0, I is less than library.count, increment I, and then I could just do a write line of each of the books in the library. So just put I in there, dot toString. Need to put that blank in just to help with the overloading. And then if I run that, then we can see we get each one of the 4 series. So we've got the 0th, the 1st, the 2nd, and the 3rd going through that. Something else we can do with that though is just like with a property in more recent versions of C#, I can't remember exactly where this came in, but if you've only got a getter and it's a very simple getter, you can actually just do an arrow, and so we can just have it simpler like that, and that will behave in exactly the same way. But then the next interesting thing we can do with indexes is they can be overloaded. So they don't just have to index on integer. And we know this because that's how dictionaries work. So in a dictionary that has a key type of string, then the thing we put in the square brackets for the indexer is a string. And so we could do that as well. And actually that makes a lot more sense here, because what I could also do, if we just copy that, is I could then change that to a string that we'll call series title. And then I could simply return the series at series title. So no logic to put in there, I'm just forwarding that down to the indexer on the dictionary. But what that now means is I could do something like this. I could simply say console write line, and then we could just have library, open brackets, the Danilov quintet. Again, we've got to make sure we get the correct toString. But what that will do is just look up by the title, and then we're just getting the books from the Danilov quintet. So pretty straightforward what we can do, but you can see we can have overloaded indexes, and you can have as many as you like following the normal rules of overloading, that you just have to have different types. And those types can really be whatever makes sense in the context. If you remember a video we did a while back on hash codes, we looked at how dictionaries work, and dictionaries certainly work best if the key type has a useful hash code, which both ints and strings do. But when you're writing your own indexer, you can put in whatever mechanism you like to do the lookup. So it doesn't have to depend on hash codes at all. Obviously it does here because we're just forwarding to the dictionary, but you could do your own kind of lookup. I'm not going to make any reference to performance here. Obviously, when you're doing a lookup, you need to do it in an efficient way, but the square brackets, the indexer, allows you to do whatever you like. And in fact, we're now at a point where we can make sense of that code we looked at in the Pelican, because if we look in here, so remember this was our indexer, and just to explain what's happening here, what we have is this array of lights that represents the 6 lights that we have in our traffic light. So if we just run that up quickly, on the traffic light we've got the 3 main lights, plus we've got the 2 lights for the pedestrians, plus we've got the wait light that comes on for itself. So we've got 6 lights in there, and then we've also got an enum, just so that we can know which light is which. So red, amber, green figure, and wait. And then that's why the indexer is using as its parameter not a string or an int, but actually using this Pelican Light's enum. So it's looking up the light, so that's the return type, based on that. And then you can see all it needs to do is index into the array by casting the light enum into an int, because the array can only be looked up as an int. And obviously red will be 0, amber will be 1, and so forth. So that's what we've got there. So it's just an indexer, but an indexer on, in this case, an enum, which is, again, quite a common thing to do. Just to take a look at how that's used, so if we look and say here, there we can see something like, so we're on the Pelican, we're looking up the green state, so that will give us back element number 2, because that's what green is, and then we're getting back that whole light object, and then we can change the state of that. So our light has a property called state, and that's what we're changing in there. So that was how the enums were being used in there. But actually there's rather more that we can do with this. So let's go back to our actual example here, and let's go back into the series and actually show that with these overloading rules, we can go a bit further. So it's not just a case of overloading on the type of the parameters, but as with overloading in general, we can overload on the number of parameters. So what I'm also going to put in here is a public, and this time it's just going to return a book, and it's going to be called this, and then we're still going to have the string series title, but then we're going to have an int that I'll call book index. So what we're going to be able to do here is ask for the series and then look up the first or second or whatever book in there. And so pretty simple to do. We're going to say, again, arrow and then underscore series. And then we're going to look up on series title, just the way we did before. But then I'm going to have to, on that, do a separate lookup, because remember that has returned as a list. So now we can apply the square brackets to the list and put in our book index. So that will give us that number of the book from that particular series. And that's allowed to exist because that's a valid overload. It's distinct from the other ones that we've got there. And so although when I was doing it on the dictionary of lists, I had to do two separate indexes because they're separate operations on different collections, I can actually, in here, just do it all in one go. So I could ask for the second book, zero based remember, of the Danilov Quintet, and if we run that up, then we get that it's the third section. If I asked for the fourth book of the Chronicles of Narnia, then we get that it's the Silver Chair. So you can see that because it was declared as a multi-dimensional indexer with series title and book index, we just comma separate that in there, and that's going to work fine. And as I say, overloading rules, exactly the same as for any other method, so different types, different numbers, you can do whatever you like with that. Let's just take a quick look at what is happening under the covers there. So I'm just going to bring up the intermediate language disassembler, which is the old tool but still works for looking inside our code and seeing what's actually been generated from the C#. So if we just go into our file explorer and whiz down into bin, debug, .NET 6, and then if I just drag over the DLL into there, and then if we take a look at that, under our indexers, under book series, here we can see what it's actually generated. And you can see that what it's done is generated a property. So red triangle means property. We've got our count property already, but it's generated a property called item. So that's what we've really got with an indexer, not an actual separate concept within the intermediate language. It's just another property, but it's given it this special name of item. So we called it this in C#, but it's item in the intermediate language. But then you can see that with that, we've got the three overloads existing there, and we've got three get items that we've got listed in there. And if we'd done setters on them, we would have set underscore item as well. So that's what's happening in there. Now that's actually something that also tells us about an interesting error that we can get, because what I could do, obviously enough in the book series, I could say actually convert this one into a method. So I could have a method called item, and then in round brackets I'd have my int idx. And you can see that's a perfectly valid way to declare a method, but it's caused us problems because now if we look at the this, it says the type book series already contains a definition for item. So because putting an indexer using this in the C# causes the intermediate language to have something called item, if you have something for yourself called item, that's going to break the way that this works. So that's just something to avoid really. Don't have methods or properties called item because it may cause a clash with any indexers that you have. One last thing just to show you, let's put on something that's a bit more reasonable as a setter. So let's just turn that into an explicit get. And then on my set, I'll give that body because I'm going to put some safety code in there. So obviously I could just say series title book index equals value, but typically if you do that, you want to put something protective on there. So what I could do is I could do something like if, and then let's take the old book dot year equals and then value dot year. So what we're saying is you can change a book's title, but you can't change its year. Else, then we just throw some kind of argument exception, year cannot change. So just to show the sort of thing we can do, that you can have the getter and the setter on there, just like a property, because that's what an indexer really is, except that it's got these parameters on there. A couple of bits of good practice that aren't rules of the language, but will make your indexers work much better if you need them. One is, an indexer should only ever be able to return one value. So whatever it is you're indexing on, you want that to be unique within the set that you're dealing with. So just like it is in a dictionary. So something you wouldn't want to do, for example, is have a parameter which was something like year. So we wouldn't want to be able to look up a book on the basis of its year, simply because you would get multiple books for the same year, and there's no way that an indexer can return multiple values. It's going to return one book, it can't return multiple books. So you should make it so it really is indexing, not just doing some kind of search that could get back multiple matches. That would have to be done by a method or something like that. So that's not enforceable by the compiler or the language, but it's an absolute golden rule for how you should be developing indexes. One that is a little bit more debatable is what happens if you fail. So if we ask for a title that doesn't exist or a book that doesn't exist. Well, the rules for that are going to be a little bit different on the get or the set. On the get, I would say always that should throw an exception. If you can't find the thing you're looking for, that should throw an exception to say that it's not there. An alternative that I wouldn't really favour is you could return something like null if it was a reference type, but I don't think that's a good idea. I think that's going to cause confusion. You should just make it throw an exception. On the other hand, when it comes to the set, if you ask for something that doesn't exist, there's two possibilities. One is you could just throw an exception, but the other is you could actually create something at that position, whatever it was that they asked for that wasn't there. And we can see that that makes sense because actually both those strategies are used within .NET itself. So, for example, if I go back to the program and let's now introduce, say, a list. So let's have a list of int that we'll call ilist and just create the object. And then let's also have a dictionary of int, int, and we'll just call that idict. And then if we try to access something in the list that isn't there, so if I say ilist square brackets 2, there's nothing there at all because it's empty, equals 27, and we run that, then that gives us an out of range exception. If on the dictionary I did something like try to write idict 2 again, once again that throws an exception because there's nothing there at position number 2. But with a dictionary, what I can do is if I say idict 2 equals 27, on a dictionary that is valid. Even though we don't have an element number 2, as soon as we ask for an element number 2, we get an element number 2, and so you'll assign in there, and then when we read it out, that's working okay. So it's up to you to decide, in our case with our book series, what would logically make sense. If we ask for a series title that doesn't exist, should we simply throw the exception, or should we create a series with that title? So up to you, depending on the context that you have. So that was it, our quick look at indexers. Very fundamental feature of the C# language, been around since day one. The example that I had there with the books and the series, that shows us lots of things we can do with them in terms of the overloading of indexers. I'm not sure it's a particularly practical example. However, I think the example we had in the traffic lights, where I had this indexer here with the enum, I think that is a good practical example. And the reason I think that is because this code wasn't there to show it off. This code was showing off the state pattern, and I just did that because I thought that was the best way to do this. So that sort of thing is quite a nice use of the indexing. So hope you enjoyed that. Talking about indexes has actually led me to think of another area of interest, which is with both indexes and properties, how sometimes the rules of encapsulation can get a bit messed up in .NET. So that's what I'm going to be talking about next time. But for now, if you enjoyed that, do click like. If you do want to see that next video and don't want to miss it, do subscribe, and I'll see you for that.